Hi folks, this is using proof of induction for inequality proofs. So the first thing we're going to do here is, if you look at the question, so we're going to show that 2 to the power of n, for when n is any number, is greater than that number squared. So now this is important here. It says that n is greater than or equal to 5. That means that the lowest value n could be is 5. So instead of showing true for n equals 1 here, I'm going to show true for n equals 5 first, because that's the lowest value that n could be. So 2 to the power of 5 is greater than 5 to the power 5 squared. So 2 to the power of 5 is, you can put that in the calculator, you get 32. So 2 times 2 times 2 times 2 times 2. So that should be greater than what 5 squared is. So 5 squared is 25, so that checks out. So that's true. So we've done the first part. Now we're going to assume true for n equals k. So if I put a k in instead of the n, so 2 to the power of k is greater than k squared. So we're just going to leave that, and we're just going to assume that that is true for the next part. So if I put a k plus 1 in instead of n, then I get 2 to the power of k plus 1 is greater than k plus 1 to be squared. Now the assumption, I'm going to put it back in here. So we said in the assumption that 2 to the power of k is greater than k squared. Therefore, if I was to multiply both sides by 2 there, I would get 2 to the power of k times 2 is greater than 2k squared. And that is the same thing on the left hand side, is the same thing as 2 to the power of k plus 1. So that has to be greater than 2k squared. So because we know that this is is less than 2 to the power of k plus 1, well, if we can just show that this thing is greater than our k plus 1 squared, well then we have it proved. So we know that 2 to the power of k plus 1 then would have to be greater than k plus 1 squared. So we're going to show that now. So we're just going to show that 2k squared is greater than k plus 1 squared. So if I squared out the sides, I would get, well, the right hand side, I'd get k squared plus 2k plus 1. That's just expanding out the double brackets there. And then if I move everything to the left hand side, I get k squared minus 2k minus 1 is greater than, greater than 0. Now another important part in here is what I'm going to next. I'm going to complete the square. So look up how to complete the square if you're not sure how to do it. But that means, by completing the square, it means I'm going to get something squared on the left hand side here. And when you have something squared, you know that that has to be greater than 0. And that's how we're going to finish out the proof. So to complete the square, I'm going to take half of the value in front of the k, which is minus 2. So half of that will be minus 1, and square it, which will give me 1. And then I'm going to add and subtract that. So plus 1 and minus 1, and then there's still a minus 1 there as well. That's completing the square. So if you're not sure how to do that, look it up, but that's basically what I just said there. So that there then is the perfect square. It's k minus 1 squared. And then we still have minus 2 on the out here. And then that has to be true then, because we set up above that our k, our n has to be greater than or equal to 5. So that was part of the question. So that's in the question, that we have k down here then, so that has to be greater than or equal to 5. So if you were to imagine you put a 5 in there instead of the k, that would be 5 minus 1 squared. So that would be 16 take away 2, which would be 14. So that is greater than 0. And then if you were to put a 6 in, it would be something bigger again, because it would be 6 minus 1, so that's 5 squared minus 2, which is 23. And then if you were to put a 7 in, or an 8 in, or a 9 in, it's only going to go up. So it's only going to be something greater on this side. So that's it then. So we've proven that. So here's another one. If you want to try this yourself, you can, and play it on, and I'll go through the answer. So this time it's an n factorial is greater than n, or 2 to the power of n. Right, so our first part here anyway, I'm going to show that it's true for n equals 4, because in the question the smallest value of n is 4. So 4 factorial is greater than 2 to the power of 4. So 4 factorial, you can do it on the calculator if you want. Just means 4 times 3, which is 12, times 2, which is 24, times 1 is 24. So we get 24 there, is greater than 2 to the power of 4. So that's 2 times 2 times 2 times 2. So that's going to be 16. So we've shown then that it's true for n equals 4. Now I'm going to assume that it's true for n equals k. So that's k factorial is greater than 2 to the power of k. So those, if you're able to get those bits, you've got some of the marks at least. Then the last bit's obviously going to be the hardest bit again. So we need to show that k plus 1 factorial is greater than 2 to the power of k plus 1. So I'm going to take the assumption again. So what we assumed there was that k factorial is greater than 2 to the power of k. So we know that straight away. So if I was to times both sides by k plus 1, so we've got that assumed there. Now we also know that k plus 1 factorial, if you think about it, k plus 1 factorial is the same as k plus 1 times by k factorial. So we're showing that that is greater than 2 to the power of k times 2, because that's the same thing as 2 to the power of k plus 1. So now you notice then that this here and this here are the same thing. So we then need just to show that this is greater than this, and that will show the proof. So 2 to the power of k times k plus 1 is greater than 2 to the power of k times by 2. So this will be the end of our proof then. So that is obviously true then for anything if k is greater than is anything greater than 1. So is true for n is where k is greater than 1. So if you were to put in a 2 there in anywhere, so like if it was 2 to the power of 2 and then 2 plus 1 in here, so that would be 3. So you'd get 4 times 3, and over on the other side you would only get 4 altogether. So this side will go up then the higher the number of k is. So whatever value you put in for k. So that's true then. So k plus 1 factorial is greater than 2 to the power of k plus 1. So we've shown then that it's true for n equals k plus 1.